This is the corner of what we call the fodder or forage field in the Denbrook catchment. The field's got an area of approximately 4 hectares, and historically over the last 2 years it's been down to maize, and then last year kale undersown by grass. As you can see, it now has a fairly decent grass sward coverage, although if you do look closely, what you'll see is that it doesn't cover as well as a well-established grass sward as we see in some of the other fields. It was suggested that a significant proportion of the 6 kilos per hectare per year of phosphorus that were yielded at the catchment outlet came from this field, particularly when it was down to maize. And so we started monitoring this field actually about 18 months ago, just after the maize was removed, when the kale and the undersown grass was in. What we found, interestingly enough, is that we still yield large volumes of water, high yields of sediment, similarly high yields of phosphorus from this field when it was kale undersown to grass. And we're monitoring again this year, fully expecting that even though it's got a good grass coverage, we're still going to yield high volumes of water and large amounts of sediment and nutrients as well. So a bit of detail about how we're trying to understand this really important source within the overall Denbrook catchment. Well, we've built a marine ply weir here. It's just a V-notch weir which allows us to still the water upslope, measure the flow depth through the V-notch, and then rate to discharge with a stage discharge calibration. The calibration thus far has been constructed coming out during natural rainfall events, capturing known volumes of water in these small drinking troughs over certain time periods and measuring corresponding flow depths. We measure the flow depths during those calibrations both through the depth of water measured by a steel tape in the V-notch, but also with a bubbler device here, which is effectively a pressure transducer that forces air through a tube in this small green tube stilling well that allows us to know what the depth is. There's ongoing calibration work to provide us with a nice idea of the levels of uncertainty in our stage discharge relationship, but suffice to say we've already got pretty confident ideas of the discharges fluxing through this flume, and they're surprisingly high. We see water depths of up to ½ a metre flowing through this flume from just 4 hectares of land. Significant contributions to the overall water budget, and of course, as I've mentioned, the sediment and phosphorus budget. The way in which we're trying to understand the sediment and phosphorus yields is by taking pump samples. We've run a whole year of taking 1 litre pump samples on variable time steps through each event, so that we've built up some interesting relationships between discharge or flow and sediment concentrations or sediment loads, phosphorus concentrations or phosphorus loads. We see classic hysteresis behaviour here, peaks of sediment and indeed phosphorus concentrations preceding the peak of the hydrograph. So what we think is a fairly banal and non-responsive grass landscape proves to be very different when we actually start to monitor out in the field, and it's our suggestion that these sort of landscapes need to be better understood in terms of the particularly the yields of sediment and nutrients, but also in terms of the yields of pathogens that we see during storm time throughout the hydrological year. So ongoing work here is to continue monitoring, really just for the hydrology this year, whilst we work up last year's data on the sediment and nutrient budgets. In addition, it's to continue monitoring at the catchment outlet may just be able to make out the shed which defines the 48 hectare catchment outlet here, and therefore to understand the different flow paths within the catchment and how they all contribute to the overall budget of sediment and nutrients within such a grassland environment.